any quadratic equation can be written in the form ax squared plus bx plus c equals 0, so that the a is not equal to 0. If the a was equal to 0, you'd have 0x squared, which is just 0, and so that equation would become bx plus c equals 0, which is a linear equation, not a quadratic equation. So any quadratic equation can be written like that, so that the a is not equal to 0. If we do that, then we can factorise that quadratic expression on the left-hand side and rewrite it as a lots of x squared plus b over ax plus c over a. And that would equal 0 as well, because we've just rewritten that first expression in a different way. But if we look at this new expression, this one here, we've got a product of two things, the a and the quadratic expression inside the bracket. And if the product of those two things is 0, and the first one, the a, is not equal to 0, then the second one must be equal to 0. So I can update that line really. I can get rid of the a and the bracket, and I can just say that that quadratic expression there must be equal to 0. So if that quadratic expression there is equal to 0, and I subtract c over a from both sides, I get x squared plus b over a x equals negative c over a. I've just subtracted c over a from both sides now. And that expression on the left-hand side, we can complete the square on that. So if we complete the square on this expression here, we halve the coefficient of x and we get x plus b over 2a squared. That's equivalent to x squared plus b over a x plus b over 2a squared. So this expression here is equal to that expression there. That's the same as that there, but with a little bit added on, this extra bit here. So if we replace this with that, then we're adding this much to the left-hand side. So to keep the equation balanced, I'm going to add that same quantity, b over 2a squared, to the left-hand side, to the right-hand side, sorry. So b over 2a squared, subtract c over a. I've just added this much here to the right-hand side. And so now this, does equal that expression on the right-hand side. Now, if I want to square a fraction, the square of a fraction is equal to the square of the numerator divided by the square of the denominator. That's always true. And so I've got b squared over 2a squared, subtract. Now I could leave that as c over a, but if I multiply the numerator and denominator both by 4a, I get 4a times c and 4a times a. 4a times a is 4a squared, and 4a squared is just 2a all squared, which means those fractions now have the same denominator, and so I can rewrite that fraction, or those two fractions, as a single fraction, b squared subtract 4ac all over 2a squared. So I'll just update the left-hand side, x plus b over 2a. I'm not changing anything, just bringing it down from above there so you can see it all in the same place. X plus b over 2a squared is equal to b squared minus 4ac all over 2a squared. If I square root both sides then, I get x plus b over 2a, not squared anymore, equals the square root, either positive or negative, of b squared minus 4ac all over 2a squared. And the square root of that quotient, that fraction, is equal to the square root of the numerator divided by the square root of the denominator. Now, the square root of 2a squared, the square root of anything squared, is just the thing itself. So the square root of something squared is just the thing itself, so I can get rid of all of that. So x plus b over 2a equals plus or minus the square root of b squared minus 4ac all over 2a. And if I subtract b over 2a from both sides, if I subtract b over 2a from both sides, I get x equals minus b over 2a plus or minus the square root of b squared minus 4ac all over 2a. And again, we've got two fractions with the same denominator, so I can combine them. Minus b plus or minus the square root of b squared minus 4ac, all of that divided by 2a. And that's the quadratic formula that you may well have seen before. So x equals minus b plus or minus the square root of b squared minus 4ac, all divided by 2a. It comes from completing the square on the general quadratic equation.